Welcome back to my YouTube channel. In this video, we'll see continuity at a point, that is a continuous of a function, and some examples related to continuous of a function. They will ask one 4-mark question on continuity at a point. See the definition of continuity at a point. A function f of x is said to be continuous at a point x equal to a. See, f of x is the function and a is said to be continuous at x equal to a. See, f of x is function and we are telling f of x is continuous at the point x equal to a. If left hand limit of f of x at x equal to a is equal to right hand limit of f of x at x equal to a is equal to value of f of x at x equal to a. That is, if at x equal to a, left hand limit is equal to right hand limit is equal to the value of the function at x equal to a, then the function is said to be continuous. Otherwise, the function is not said to be continuous. Remember, f of x is the function is said to be continuous at x equal to a. F of x is one function and it is said to be continuous at x equal to if left hand limit is equal to right hand limit is equal to yes, the value of the function at x equal to a. After that, we are having the value of left hand limit. So left hand limit is given by limit of x tends to a bar f of x. This a bar tells that you take the value of the function f of x on the left of x equal to a, right? Yes, a bar indicates that, a bar tells that you take the value of f of x on the left of x equal to a, and right hand limit is limit of x tends to a plus f of x. This a plus indicates that you take the value of function f of x on the right of x equal to a. X tends to a plus indicates that you take the value of f of x on the right of x equal to a, right? Next, yes, note, it is very important. To evaluate LHL of a function f of x at x equal to 0, you always take the value of x equal to a minus h. When you are evaluating left hand limit at x equal to 0, at that time you take x equal to a minus h, and when you are finding or when you are evaluating right hand limit, at that time you take the value of x equal to a plus h, right? So these things are very important, you remember. Next, I go for the examples which is based on continuity at a point. Yes, examples based on continuous of a function. Example, find the value of k, such that the function f is continuous at the indicated point, The first example you are having f of x is equal to kx plus 1 if x is less than or equal to pi, and it is cos x if x is greater than pi, and the function is continuous at x equal to s pi. See, see the example. find the value of k. So k is unknown, you should find the value of k such that the function f is continuous at the indicated point. So given function is continuous at the indicated point. See, they are given the value of function f of x is equal to kx plus 1 if x is less than or equal to pi. It means when you have the value of x equal to pi, at that time you take the value of function is kx plus 1. Or for all the values of x which is less than pi, then the value of f of x is also kx plus 1. And for all the values of x greater than pi, the value of the function is cos x. And already this function is continuous at x equal to s pi, right? So I go for a solution of this. So I'll write given f of x is equal to kx plus 1 if x is less than or equal to pi. If x is less than or equal to pi, and it is cos x if x is greater than pi. X is greater than pi, and after that you take x equal to s pi. Now already they are given function is continuous at x equal to pi. So therefore I'll write, yes, we are having left hand limit is equal to right hand limit is equal to, yes, we are having a f of pi. So why we are having left hand limit is equal to right hand limit equal to f of pi means because already function is continuous at x equal to pi. They are given function is continuous at x equal to pi. When function is continuous at x equal to pi, then you take a left hand limit is equal to right hand limit equal to f of pi. Left hand limit is same as right hand limit, and that is equal to take f of s pi. So therefore I go for the value of left hand limit. So left hand limit is equal to, see, left hand limit is equal to LHL is equal to, I will write limit of x tends to pi bar f of x, you write x tends to pi bar f of x. So why here pi bar means we are discussing, yes, we are finding the value of k, and already they are given the function is continuous at x equal to pi. So now this is equal to limit of x tends to pi bar. This pi bar indicates that you take the value of function when the value of x is less than pi. For the value of x is less than pi, you take the value of function f of x is equal to kx plus 1 here, right? And you take here f of x is what? Yes, kx plus 1. Kx plus 1, kx plus 1. Now this is equal to, you drop the limit and take the value of x equal to pi in this one. So therefore k into pi plus 1. So this is equal to k pi plus 1. This is the value of left hand limit. Next you go for the value of yes, RHL. You go for right hand limit. So therefore I go for right hand limit. So right hand limit is equal to limit of x tends to pi plus f of x, you write. So now this is equal to limit of x tends to pi plus, and here you take the value of function when the value of x is greater than pi. For pi plus we take always the value of function, take the value of function when x is greater than pi, and for x greater than pi the value of function is cos x. So you write here cos x. Cos x, you write, and now you drop the limit and take the value of x equal to pi. So you will get cos pi. It is the cos pi, and this is the value of s RHL. So RHL is equal to, right, cos pi, right? And after this you go for the value of f of pi. So I go for the value of f of pi. So f of pi means the value of the function at x equal to pi. F of pi means the value of function at x equal to pi. See, at x equal to pi, the value of function is kx plus 1, and at x equal to pi, the value of function will becomes k into pi plus 1. So here f of pi is k pi plus 1. So these all values you have to take yes in this equation. All right, in this equation you take. So I'll write this is 1. All right. So therefore I'll write equation yes 1 becomes equation 1 becomes so therefore yes, LHL values we are having a k pi plus 1 is equal to RHL value. So RHL value is what we are having, cos pi and is equal to f of pi, it is k pi plus 1. So here also we are having k pi plus 1 and here also k pi plus 1. So you drop 1 k pi plus 1 and you write a k pi plus 1 is equal to yes, cos pi. So therefore k pi plus 1 you write as it is, and the value of cos pi we are having, the value of cos pi is what, minus 1. The value of cos pi is minus 1 you write, right? So therefore I'll write k pi is equal to minus 1 as it is, you take plus 1 on this side, it becomes minus 1. So therefore k pi equal to minus 1 minus 2. So therefore k equal to, we are having a minus 2 divided by pi. The value of k is minus 2 divided by pi. So very important example, you remember. Next example, I go for next example, that is second one. This example is very important. They asked this example so many times. Yes, f of x equal to, we are having second example, f of x equal to 1 minus cos 2x divided by 1 minus cos x. If x is not equal to 0 and it is k, if x equal to 0 and already they are given function is continuous at x equal to 0. Function is continuous at x equal to 0. Function is continuous at x equal to 0. They asked this example in 2016 March. So very important. They asked this example in 2016 March, right? See. See, f of x equal to, they are given 1 minus cos 2x divided by 1 minus cos x. If x is not equal to 0. So when x is not equal to 0, we are having two possibilities here. One is x is less than 0 and another one is x is greater than 0. See, x is not equal to 0 means you take x is less than 0 or x is greater than 0, right? And for the value of x equal to 0, the value of function is k. Now already they are given the function is therefore they are given the function is continuous. The function is continuous at x equal to 0. Already they are given the function is continuous at x equal to 0. Therefore we are having left hand limit is equal to right hand limit is equal to left hand limit is equal to right hand limit is equal to yes, f of 0. This thing we have, right? And for this we call it is equation number 1. For this we call equation number 1. See, for x less than 0 and for x greater than 0, the value of function is same here. 1 minus cos 2x divided by 1 minus cos x. And the value of f of 0, see, the value of f of 0 is k, right? So first I go for LHL. LHL is equal to, I will write limit of x tends to 0 bar, yes, f of x I will write. So for 0 bar means x less than 0. 0 bar means x less than 0. For the value of x less than 0, the value of function is 1 minus cos 2x divided by 1 minus cos x. So therefore I will write limit of the x tends to 0 bar as it is f of x. See, we are having the value of f of x is 1 minus cos 2x divided by Yes, 1 minus cos x we are having. 1 minus cos x. Now, you drop the limit and take the value of x is 0. You drop the limit and take the value of x is 0 in this one. So, see. When you take the value of x 0 in this one, it becomes 1 minus cos 2 into 0, that is cos 0. And here also 1 minus cos 0. So, 1 minus cos 0 means the value of cos 0 is 1 we are having. So, cos 0 is 1, you will get 1 minus 1. And here also cos 0 is 1, 1 minus 1. So, 1 minus 1 divided by 1 minus 1, it is 0 by 0. And 0 by 0 is what? Indeterminate form. So, 0 by 0 is what? Indeterminate form. Hence, you remove indeterminate form, these terms. For these equations, you have to remove indeterminate forms. See, if you drop limit and take the value of x equal to 0, you will get 0 by 0. Alright, so indeterminate form. And by simplifying this term, you remove indeterminate form. So, therefore, we are having the formula, you know already, that is cos 2x equal to what? Cos 2x equal to 1 minus 2 sin square x. 1 minus 2 sin square x. Right? So, you take 1 in this side. It becomes yes, minus 1. Minus 1 plus cos 2x is equal to minus 2 sin square x. Right? So, minus you take common, you will get 1 minus cos 2x is equal to minus 2 sin square x. Minus 2 sin square x. Minus minus get cancel. So, therefore, I will write 1 minus cos 2x is equal to, yes, I will write 2 sin square x. 1 minus cos 2x equal to 2 sin square x. So, therefore, I will write here limit of x tends to 0 bar as it is, and after that we are having the value of 1 minus cos 2x. So, 1 minus cos 2x is 2 sin square x. 1 minus cos 2x is 2 sin square x, you write, divided by, you write 1 minus cos x. Divided by, you write 1 minus cos x. So, now this is equal to 2 is a constant, you take outside the s limit, and after that you write limit of x tends to 0, limit of x tends to 0 bar. Next sin square x. Sin square x is what? 1 minus cos square x. So, sin square x is what? 1 minus cos square x divided by this 1 minus cos x, you write as it is. Right? Because we are having the formula of sin square x. Sin square x is 1 minus cos square x. So, now left hand limit is equal to, I will write 2 as it is. Limit of x tends to 0 bar, I will write as it is. See, this 1 I will write 1 square. 1 I will write 1 square. And this is in the form of a square minus b square. So, a square minus b square is what? A plus b into a minus b. So, I will write it is 1 minus cos x into, I will write 1 plus cos x divided by, I will write 1 minus cos x. 1 minus cos x. This 1 minus cos x, this 1 minus cos x get cancelled. So, therefore, I will write left hand limit is equal to 2. Now, you drop limit and take the value of x is 0 in this one. So, write 1 plus cos x and x values are 0 because I already dropped limit. So, now this is equal to 2 as it is. 1 plus cos 0 is 1. So, 2, 1 plus 1 is 2. So, 2 to the what it is? Yes, 4. So, therefore, left hand limit is equal to 4. Left hand limit is equal to 4. Similarly, I will write the value of right hand limit. Yes, therefore, see the value of RHL. See, LHL is 4, then the value of RHL is also yes 4. RHL is also 4. And after that we are having f of 0. See, f of 0. The value of function at x equal to 0. See, f of 0 means the value of function at x equal to 0. The value of function at x equal to 0 is k. It is k. So, therefore, I will take these all values in equation S1. Equation 1 becomes, right. So, therefore, yes, we are having left hand limit is 4, right hand limit is also 4, is equal to f of 0 is k. Or you can write the value of k is 4. The value of k is 4, right. Next example I go. So, this is very important. Pause the video and take this one. Next example. Third one, we are having f of x is equal to k into cos x, divided by pi minus 2x, Next one, 3. If x is not equal to pi by 2, and here if x is equal to pi by 2, and the function is continuous at x equal to s pi by 2, and the function is continuous at x equal to pi by 2. This example is very important. They asked this example in 2014 March, 2014 June, 2017 March. Very important example it is. Alright, very, very important. See, function is continuous at x equal to pi by 2. Already they are given function is continuous at x equal to pi by 2, and you should find the value of k. See the value of f of x. K cos x divided by pi minus 2x. K cos x divided by pi minus 2x if x is not equal to pi by 2. If x is not equal to pi by 2 means we are having two possibilities here. One is x is less than pi by 2, and another one is x is greater than pi by 2. So we are having two possibilities. When x is not equal to pi by 2, we are having two possibilities. So for x less than pi by 2, we are taking the value of function is this one, and for x greater than pi by 2, we are taking the value of function is k cos x divided by pi minus 2x. And for the value of x equal to pi by 2, we are taking the value of function is what? 3. F of x is 3 we are taking. Alright. So now I go for a solution of this. Solution. Yes, given I'll write f of x is equal to k cos x divided by pi minus 2x, and it is 3. This is yes, if x is not equal to pi by 2. If x is not equal to pi by 2, x is not equal to pi by 2 means yes, here we are having two possibilities. One is x is less than pi by 2. For x less than pi by 2, we are taking the value of function is k cos x divided by pi minus 2x, and for x greater than pi by 2, we are taking the value of function is k cos x divided by pi minus 2x, and at x equal to pi by 2, the value of function is 3. Right. So now already they are given. Yes, the function is continuous at x equal to pi by 2. Already they are given function is continuous at x equal to pi by 2. See, when function is continuous at x equal to pi by 2, we have here left hand limit equal to right hand limit equal to f of pi by 2. So therefore I'll write yes, LHL is equal to left hand limit equal to right hand limit equal to yes, f of pi by 2. So you calculate left hand limit. So therefore yes, left hand limit is equal to limit of x tends to pi by 2 bar, you write f of x. So now this is equal to limit of x tends to pi by 2 bar f of x. See the value of f of x. The value of f of x is yes, k cos x divided by yes, pi minus 2x. See, for the value of x is less than pi by 2, x tends to pi by 2 bar means what? For the value of x is less than pi by 2, that is on the left of x equal to pi by 2, you take the value of function is k cos x divided by pi minus 2x. For the value of x less than pi by 2, you take the value of function f of x is k cos x divided by pi minus 2x. Now see, you drop limit and take the value of x is pi by 2 in this one. See what it becomes. You drop limit and take the value of x is pi by 2 in this one. So you will get k into cos of pi by 2. K into cos of pi by 2. So k into cos pi by 2 means cos 90. So cos 90 is what? 0. Right. Next pi minus 2 into pi by 2. 2 to get cancelled. Pi minus pi 0. So you will get indeterminate form. You will get indeterminate form, and that's why you take here yes x is equal to pi by 2 minus h. You take here x equal to pi by 2 minus h as h tends to 0. You take the value of x equal to what? Yes, pi by 2 minus h as h tends to 0. I am going for a substitution method, because when you drop the limit and take the value of x equal to pi by 2 in this one, you will get 0 by 0 indeterminate form. To remove this indeterminate form, just I took here the value of x equal to pi by 2 minus h as h tends to 0 in this equation. So I call this is a left hand limit, and we call it is equation number 1. So therefore I will write equation yes 1 becomes equation 1 becomes right. So therefore I will write left hand limit is equal to limit of h tends to 0, because I am using substitution method here. I am taking here the value of x equal to pi by 2 minus h. That's why I written limit of x tends to pi by 2 bar to limit of h tends to 0. Next you write s k cos x. So cos you write x means it is pi by 2 minus h divided by pi minus 2x. 2x means it is pi by 2 minus h. Pi by 2 minus h. Right. So now this is equal to limit of h tends to 0. Limit of h tends to 0. K into yes cos of pi by 2 minus h. You write as it is. Pi by 2 minus h as it is. You write. Yes, cos of pi by 2 minus h, you write as it is, and after that we are having pi, you write as it is. You simplify minus 2 into pi by 2. See, minus 2 into pi by 2, 2 to get cancelled, you will get minus pi here. Next minus into minus plus, and it is 2h. Yes, bracket complete. See once again, k into cos of pi by 2 minus h are written as it is. Next one, pi as it is, minus 2 into pi by 2, 2 to get cancelled, pi minus into minus plus 2h. So now this is equal to, yes, we are having k constant, this minus plus pi get cancelled. Limit of h tends to 0, you write as it is. Now see, cos of 90 minus theta. Cos of 90 minus theta is what? Sin theta. See, cos of 90 minus theta is sin theta. Cos of 90 minus h is sin h. It is sin h divided by s2h. Divided by 2h. Now you take a 2 outside, it becomes a k by 2. Limit of h tends to 0. Sin h divided by h. Sin h divided by h. So this is equal to k by 2. Limit of h tends to 0, sin h divided by h, its value is 1. So k by 2 into 1 is k by 2. It is k by 2. This is the value of left hand limit. So left hand limit is equal to k by 2. And similarly you get the value of RHL is also k by 2. So RHL is also what we are having, k by 2. See, RHL is also, yes, we are having k by 2. So I will write RHL. Similarly, the value of RHL, yes, similarly the value of right hand limit is also, yes, k by 2. K by 2, because yes, for the value of x less than pi by 2, we are having the value of function is this one, that is ks cos x divided by pi minus 2x, and for x greater than pi by 2, the value of function is also same. Next one you go for f of pi by 2. So f of pi by 2 is we are having here 3, right? And since already we have left hand limit is equal to right hand limit is equal to f of s of pi by 2. So left hand limit is k by 2, right hand limit is also k by 2, f of pi by 2 is 3. So therefore I will write the value of k is equal to, we take 2 in this side, it becomes 3 into 2. So therefore the value of k is 6. The value of k is 6. So these examples are very important. Please try these all examples. Please share, subscribe my channel. Share and subscribe my channel. Thank you for watching.